So this is this problem on page 58. How do we find f of g of h of x? Now, when you're dealing with composite functions, what you got to worry about is what is the inside function, what is the outside function. So let's see, let me get a highlighter here. So if I'm looking at this, I see that the innermost function is h of x. So that's what goes inside of g of x, because we see how g is the next function that's nested inside. So this tells us I'm going to substitute h, the h function, into the g function. So every place I see an x in the g function, okay, so that's the g function, 1 over x. So I'm going to replace that with x plus 3. So I'm going to take that function and replace it into that for that x. So that's what, now this represents g of h of x. Okay. So now we're going to go work our way back out, and f is our outside function. So I go to the f function, and I see it's x squared plus 1. So I'm going to replace whatever the x is, and then I'm going to try to clean it up. So this is going to get substituted in there. So that's certainly an answer. That's an answer to this. Now we probably should start working on cleaning things up a little bit. So when I square a fraction, that's the same thing as squaring the numerator, squaring the denominator. So 1 squared is 1. And certainly all right. In fact, as you get into calculus, leaving your denominators factored is the best way to go, because it really makes it easier to see things. But we probably want to make this be a single fraction. So what I'm going to do is I'm going to think about this as being over 1, and my common denominator is going to be x plus 3 quantity squared, right? This here. So I'm going to multiply this fraction by x plus 3 squared over x plus 3 squared, quantity squared. And that's going to leave me 1 over x plus 3 squared plus that whole mess, because that's just 1. And you'll certainly start taking shortcuts with this. But I'll walk this out in detail here. Now I've got common denominators. I can just combine the fractions. So that's 1 plus the quantity x plus 3 squared over that denominator, x plus 3 squared. Now to clean this up a little bit, we could expand we can expand out the numerator. So that's going to leave me 1 plus, and if you remember your foiling tricks for multiplying two binomials, this is a perfect square binomial. So I'm going to, if I remember first, is x squared. Then the outside is 3x, the inside is 3x. I'm going to add those together and get 6x. And then 3 times 3 is 9. Okay, and then we can combine like terms in the numerator. And we're going to get x squared plus 6x plus 10. And then for me, for like a quiz or a test where you hand in work to me, leaving that numerator in factored form like that, or denominator in factored form, is certainly acceptable. My open math, sometimes you're a little picky and they'll want that expanded out. You'll have to see what they're looking for in each problem. Okay, so that's how you clean up that question, and really in detail. Hope that helps.